So I'm working as a design structural engineer at Dr. Kesali Associates, and I'm working as an instructor with this academy for the design of high-rise building, right? So all of you know about the course contents, that what we will be covering in this course. In the first session, that will be a general discussion, which will be we will do time to time in each session, and then we'll move towards the type of the building systems, and this will be a brief introduction because this is a bit advanced designing, in which we do not go in detail for the beginning, right? Because I will assume that you have done your BSc and MSc, and you know what is different type of slabs in building system, but we will review that in briefly, right? And then we'll move towards the introduction of the different building codes, which includes the ACI 318 and AC 710 or 716, and then Building Code of Pakistan and UBC 97. Right, so let us move towards the first session. And in the first session, that we will be covering the type of building frame system. And it is very important for an engineer to decide which type of frame system he will be designing, or we will be designing as per the architectural requirement. And you will be designing a tab or Excel sheet, whatever, because nowadays the Excel sheets are now has been excluded in the design, and normally all of the design is done using the ETABS and other different softwares. So in the first part in this session is the type of building frame system, which is basically divided in different system in accordance with the resistance of the lateral forces, that what type of the frame system are there and how the code guide you to design that, what will be the response modification factors and all of these. In the building frame system, the first system, which is very basic and typically found in Pakistan, that is the wall bearing system, in which all of the loads is resisted by the walls. You can see in the figures that on the left side, you can see it is the wall bearing system, in which all of the loads will be resisted by these blocks, which is the concrete blocks. And these wall bearing system can be made of the brick masonry, it can be concrete block masonry. And you can see on the right side, the figure, the system is the wall bearing system, in which all of the loads is resisted by the walls. And these are the masonry or the brick wall is made of the bricks, right? So this is the first bearing system. You can also design it in ETAB or in any other softwares, right? You will design it as per the requirement or as per the architectural design. And normally the residential buildings are of the wall bearing system, right? The next framing system is the building frame system, in which the loads are resisted by the shear walls as well as the frame structure, that is the frame, beam, column, and slab, and the lateral loads, which are coming from the earthquake forces or coming from the wind or blast loading, and these will be mainly resisted by the shear walls, and the gravity loads will be resisted by the frame structure. You can see in the figures that the shear walls has been given at each edges. You can see an L shape, and also given at the center like a single shear walls, and you can also is in the shape of the core walls, right? So all of the lateral forces will be resisted by these shear walls, and the frame structure will be designed only for the gravity loads, right? You can do that in ETAB by excluding the load combination, which includes the earthquake forces, and you can design the frame structure only for those combination, which includes only gravity loads. So this is the system in which you will resist the lateral forces by shear walls, and you will resist the gravity loads, super dead loads, or the live loads with the help of the beam column connection, which is called as the frame structure. So this is the another type of the building structural system. The next is the moment resting frame system, which is very common, and we will be designing this system in our course. In this system, the all loads, gravity plus lateral, are resisted by frame structure. Means the beam column will resist the gravity loads as well as the loads, the dynamic loads coming from the earthquake or coming from the wind or blast loading. All of these will be resisted by the frame, right? So the action of the shear walls or the lift walls, it depends upon the torsion irregularity and the drift. So you will be introducing these shear walls as per the requirement, but the basic system which will resist all of the loads, which will be the gravity loads plus the lateral loads, that will be the frame structure. So this is very commonly used in all around the world, and it is very safe. Please turn off your mic, please. So this system is normally used or commonly used in Pakistan and all around the world, right? And this is very safe and very economical structure as compared to other systems, which will be discussing one by one, right? So the fourth system is the dual system, in which the gravity loads are resisted by the frame structure only, and the shear walls will give you some resistance to the lateral forces. For example, there is no restriction on the percentage. If you want to give, for example, if an engineer want to give 75%, if the engineer wants to resist 75% of the lateral loads by the frame and 25% of the load to be resisted by the shear walls or core walls or lift walls, so we can do that, right? So there is also a section in the code that you can start from the 25%. That 25% of the lateral loads will be resisted by the shear walls, core walls, or lift walls, and you can resist 75% of the load by the frames or 25% load by the shear walls. You can also do by 50-50, that 50% load resisted by the frame and 50% load by the shear wall. So it depends upon the designer, but code gives you the advice or the direction to start from the minimum 25% to give the 25% lateral loads to the shear walls. But what happens in our design, what we do, we actually design our structure for the moment resisting frame, which we do not design our structure as a dual system, because there are some other requirements for the system to be dual system, right? So what we do in a daily design in our consultancy, that we design our structure as a moment resisting frame system, and we introduce the lift walls, the shear walls, and the core walls in order to fulfill the requirement of the torsion irregularity or the drift, and we resist the 100% lateral loads on the shear walls and lift walls, right? So we design that you can design it independent, and you can design it with the overall frame to give some reliefs in the criteria of the torsion irregularity, completion, and the drift, right? So you can also design that as a dual system. It depends upon designer, whichever he want to design, right? So this was the whole story about the different frame system, and there is also some tables and requirements in the code, which we will discuss in a few minutes. The next is the type of the slab systems, in which we includes the slab beam system, which we have discussed, that the moment resisting frame system, and all of these are the.
Excuse me, sir. Sir. सर क्वेश्चन है.
काइंडली आप अपने साथ क्वेश्चन नोट कर लिया करें और लेक्चर के एंड में आप क्वेश्चन कर लिया करें, जितने भी क्वेश्चन अपने साथ नोट कर लिया करें, ठीक है? The type of slab systems, all of these are the moment resisting frame system, but there's different configuration of the slab system. The first one is the beam slab system, flat slab system, and flat plate and the joist system. So let us discuss it one by one. The beam slab system, in this system, the loads are transferred through beam slab action to the columns. And this system may be one-way or two-way beam slab system. You can see on the left side, this system is a one-way slab system, and this system is a two-way slab. So I assume that you know what is one-way slab and what is two-way slab, but let me discuss it, that we have to divide the longer length, for example, LA, this is longer length and this is the shorter length of the span. And if this value is greater than or equal to 2, right? So if this ratio is equal to or greater than 2, so it will be considered as a one-way slab, right? And if this value, if this LA by LB, this is the longer length of the span, this is the shorter length of the span. If it is less than 2, so it will be designed or considered as a two-way slab, because the CI requirement, minimum requirement of reinforcement and maximum, these are different from one-way slab and two-way slab, right? So two systems can be possible in the beam slab system, which will be one-way slab and the two-way slab. And these are the different chapters available in the ACI code, and that is chapter number, I think it's 6 and 7, which is the one-way slab and two-way slab. And you can find different requirements: minimum thickness, minimum reinforcement, maximum spacing of the bars, and all of these requirements. You can fulfill that in the ACI code. The next slab system is the flat slab system. And in this system, the loads are directly transferred to the columns and there is no beams involved. You can also add some additional elements, which is also known as the column capitals and drop panels or drop slabs, or you can also add the integral beams if it is required. And these are used with the columns to resist the punching moment, because in this system, the major issue is the punching, right? Because in the beam slab system, beams resist the punching, so there is no issue in their system. But normally the system used in Pakistan and all around the world is the beam slab system. But where you can use the flat slab system, if the architect says that I need the more clear length, more clear height of the story, and if he says that I do not want to use any beam, there is a drop of the beam, it will decrease the clear height of the story. So he will ask to design this system without the beam. So you will go towards the flat slab system, and there will be only a drop at the periphery or at the near the support or the under the column. So the other floors will be with no drops or no beams, right? So you can see in the pictures that this is on the drop panels, it has been provided under the column. You can see on the other photo as well. And there is also a combination of the column capital and drop panel. And the last figure is only the column capital, right? So the major issue in this system is the punching. If you can resist the punching, you can design this system. But there is also restriction of the code that you cannot design the system in zone 3 and zone 4, right? In zone 3 and zone 4, you must go for the beam slab system. The next is the flat plate system, right? In this system, again, the loads are directly transferred to the columns, and you can add additional elements, which is known as the integral beam, to resist the column loads and to resist the punching demand, right? So there is also, if the architect says that I also do not want any drop panels on any column capitals, it will not be looking good as per the architectural design. So I want only a flat slab, so there is no column capital and drop panels. So in that case, you must go for the flat plate system, in which you must design your columns for the punching, and you must design the integral beam for that system as well. Again, the code says that you cannot design this system in zone 3 and zone 4. You must go for the beam slab system, right? The next and the last and the most important slab system is the joist system. In this system, the loads are also transferred to the beam slab action to the columns, and it may also be one way or two way, which I've already explained earlier that what is two way and what is one way. And you can see that this is also this, you can see these are the small beams. It is known as joist. It is also called as ribs, right? So it is called as one-way joist system, or it is called as rib slab system, or you can say it is as rib slab. It is also called as a rib slab. On the right side, you can see these small beams running in the both direction. It is two-way joist system, and it is also called as a waffle slab system. If you open SAFE software, you will find these terminologies. There is no terminology used as a joist. In these softwares, it is used as a rib system, rib slab system, which is one-way joist. And the waffle slab system, it is known as the two-way joist system, right? So how we do decide that it is, for example, a student may ask that it is same as the beam slab system. So how can a student differentiate between the joist system, two-way joist system, or a two-way beam slab system? So if the clear distance, for example, if I show it here, for example, this is a section, this is the slab, and this is the one beam, this is another beam. If this clear distance between the two beams, if it is equal to or less than 36 inches, right, 3 feet, so it will be categorized as a joist system. It may be one-way joist, it may be two-way joist. If it is the clear distance between the adjacent beams is greater than 36 inches, it will be classified as a beam slab system, right? So this is the major difference, and you can, if you have done MSc, you have studied that. If you haven't done any MSc, you will learn in the advanced reinforced concrete design, right? So this was the overall brief introduction to this slab system and the structural system. Let us go towards the codes. For example, if I go to this is the Building Code of Pakistan, which is Seismic Provision 2007. The new code has also been introduced in Pakistan, but yet is not functional, right? So you can find out the different chapters in this code, and this is the chapter 1, and this is about the scope. What is the scope of this code? The second chapter is the seismic hazard, right, in which it will give you the information about the different seismic zones, what is the peak ground acceleration for different zones, zone 1, 2A, 2B, 3, and 4. And then it will give you the information about the seismic zone of the Pakistan, that what is the seismic zone of different cities. For example, if I talk about the let us search it for the, for example, if I talk about the Sawabi Lahore, if I talk about the Charsada, so it lies in the seismic zone of 2B. In this way, you can find any city in Pakistan that in which zone it is, right? So this is the chapter 2. The chapter 3 about the site consideration, which will give you about the soil and foundation information about the what is CA, CB, CC, CD. And if you have used ETABS, you may know that in the definition of the earthquake forces, software will ask you what type of the soil is, if it is SA, SP, SC, SD, right? So you will define that, and you will know about the soil profile from the geotech report of the site for the building which you are designing. The chapter 4 again is about the soil and foundation, which it will give you different information. This is the main chapter, which is the structural design requirement, right? And in this, it will give you different definitions, that what is dead load, what is fractured load, what is live load, and many other definitions you can find. You can read it by yourself, right? Or in this chapter, different loads has been defined. These are the load combination, which we will define in one of our session, that how will you define the load combinations as per Building Code of Pakistan, right? The next is the second part of this chapter is the snow load. If you are designing a structure for the snow, And the third part is the wind design, that how you will design your structural system for the wind. And the important part, the part 4, in which we are interested, is the earthquake design, in which the first is the samples and notations, and then it will give you different, how you will find the base shear, what is the procedure for the equivalent electric force procedure, right? What is the design base shear, how you can find it manually, because this scoring has been done in the ETAB. ETAB will give you automatically the final value of the base shear, right? So let us move towards the tables. You can read it out yourself. For example, these chapters are very important. This is the table 5.1, which is the uniformly and concentrated load. These are the live loads, and you have to select as per your requirement, right? So for example, if I'm designing my structure for the office use, you must go for the live load of 50 PSF, which is the 50 pound per square foot. Right? Same for the computer use. If it is a lab or library in which computer are used, you have to take the 100 PSF load, right? Same for the garages, hospital, libraries, and all of these loads. For example, the residential buildings, the basic floor area, the load is 40 PSF, and exterior balcony it is 60, and decks is 40, and storage is 40, right? Same for the other structure, it is schools, it is storage, it is stores. You have to select the live load as per your requirement. So this is the table 5.1. These are if it is special loads, so you can select it is in the table 5.2. Let me go towards the structure system table. Right, so this is the table 5.13, which is the structural system, which I have defined that. For example, the first one is the wall bearing system. The second is the building frame system and the moment resisting frame system, dual system, and these are the cantilever column system. Right? For example, if you are designing your structure as a bearing wall system, for example, if it is consists of the shear walls, and if it is made of masonry, brick masonry, so you have to take the R value is equal to 4.5, and this value is the strength reduction factors 2.8. Normally, this concept is not clear to some students. For example, if a student wants to design a member or a wall, and he wants this wall or member, column or beam to remain elastic throughout its life, so you have to use this strength reduction factor, and it will be designed as per as he designed. And the definition of the UBC code or the Building Code of Pakistan, there is no definition of the strength reduction factor in the definition in the ETAB, but in the new code, AC7 gives you free hand to give any value of the strength reduction factors when you are designing the earthquake forces, right? So in the design of the building codes, in the design of the buildings in the as per the UPC 97 of Building Code of Pakistan, it will automatically take this value from the softwares inside from the codes or tables. But in the new code, for example, if you design a structure as per ASC 716, 710, you have to insert these values manually as per your structure. So the R value is different for different structure system. For example, if I talk about the building frame system, in which the shear wall is emitted of the concrete, the R value is 5.5, right? And if it is ordinarily braced, it is the concrete, again, it is 5.6. What does it mean 5.5 and 5.6? If I move towards the moment resisting frame system, for example, it is SMRF, special moment resisting frame. And if it is concrete, the R value is 8.5, and the IMRF it is 5.5, and OMRF it is 5.5, and OMRF from the concrete it is 3.5. The R value, if you increase the R value, it means you are telling your software that your structure is more stiff, it is more redundant, right? And you have to fulfill all the requirements of the special moment resisting frame. For example, if you are designing a structure as a SMRF, you must take the R value as 8.5, but you must fulfill all of the requirements of the code which has been defined for the special moment resisting frame. For example, if you remember, the lapping criteria for the SMRF is the distance between two strips in the column or the beam center to center should not be greater than 4 inches, for example, right? If you fulfill all of these, are many other requirements that if you provide 6 bar at the top of the beam, you must provide at least 4 bars at the bottom of the beam, right? And there are other some requirements. You can search it in the code, in the ACI code, that what is SMRF and what are different requirements, right? If you are using the R value 5.5, it means you are telling your software that my system is IMRF and I'm not fulfilling all of those requirements, so I define SMRF. For example, there is no restriction on the strip spacing in the lapping. There is no restriction on the top and bottom reinforcement, right? There's no restriction on the lapping or the development lengths, right? So you can use the R 5.5. If again you are not using any provisions or any code, for example, the column reinforcement is, for example, it is not fulfilling any requirement as per the IMRF, SMRF, so you must take the R value 3.5. So what will happen if you take the R value greater or less? If you take the R value greater, for example, 8.5, the base shear will be less on the structure, right? Because you have told your ETABS that my structure is stiff, right? So the base shear will be less. So if you take the R 5.5, so base shear will be more, so more reinforcement will be required. If the R value is 3.5, so more base shear, more demand on the structure, more reinforcement will be required, right? So this is how you will decide the building system, framing system, and the moment resisting frame system, where it is SMRF, IMRF, and OMRF. And again, the fourth one is the dual system. If you are designing your system to shear walls with concrete frame, which is if you are designing your shear walls with concrete SMRF, the R value 8.5, OMRF 4.2, IMRF 6.5. And just like these are different structure systems, and you have to select your R as per your requirement, right? So this is the overall general discussion on the structural system. And this is the another code, which is the ACI 31814, and you can see these are the different chapters you can design and you can go through as per your requirement. I have told you that different chapters has been defined. For this is one-way slabs, this is chapter number 7, and there will be different requirements. What is the minimum thickness? What is the minimum reinforcement? What is the maximum spacing of the bars? Again, this is the two-way slab chapter. This is the 5 loads, and loads are the same. It is taken from the AC 716, which we will discuss. Chapter 10 about the columns. This is the chapter 9 beams, and this is the chapter structure wall, chapter 11, right? And you can go through these chapters as per your requirement. Please give me a minute. So the chapter number 13 is about the foundation, and this the 14 again plain concrete, and this chapter number 15 is the beam, column, and slab joints. And you can go through these different chapters as per your requirement. The next one is the UBC 97, and the UBC 97 is the Building Code of Pakistan and UBC 97 are same, because Building Code of Pakistan has just changed the different sections and the names, although the codes are the same, because Pakistan Building Code of Pakistan is based on the UBC 97, right? And you can go through its different chapters and it will be same as the Building Code of Pakistan. The important one is the AC 716, and it is about the minimum design loads associated for the buildings and other structures, right? If you go through its chapters, you will find out different loads. For example, the combination of the loads. Chapter 1 is the general. Chapter number 4 about the live loads. and the flood loads, tsunami, snow loads, rain loads, and all of these different kind of loads we have to select as per your requirement, right? The loads which I have shown to you in the Building Code of Pakistan, in the ACI, in the UBC 97, all of these loads are taken from this code, and it will be written in these codes that these loads has been taken from the AC 716 or AC 710 or AC 7, whichever version it is, right? So we will be using these codes in our course time to time, and I will give you a specific reference that how you can design or take the loads from the different codes, right? And we will be have different lectures. At the first, we will deliver a lecture, and then we'll move towards the modeling in the ETABS itself, right? So this was the overall story about the slab system, structural frame systems, and introduction to different codes. And the session is about to end in this Google Zoom app, and it is about 40 minutes. So I will end this session. Again, I will share a new link and you have to join it again, right? See you in a few minutes.